Good morning, Miss Terrell here. I want you to take a good deep breath, look at this dog, and just say, oh, she is something sweet. All right, now look at her tail. You can hardly see her tail because she is so excited. She's so happy. She's a wiggle worm. All right, let's get ready to talk about some circles. All right, so your job was to complete this top half of the paper, numbers 1 through 4 in the definition of a circle, so make sure that is done. And if you need help, you're going to look on pages 67 through 70 for that. All right, so for our first definition here, a semicircle and how to name it. So a semicircle is an arc whose endpoints are the endpoints of a diameter. All right, so you want to write that definition down. An arc whose endpoints are the endpoints of a diameter. All right, so let's see what that's going to look like. All right, so we're going to have a circle. All right, and you need a diameter. Okay, so let's draw a diameter. And let's go ahead and label some points. Let's call that diameter. The diameter here is AB, and let's put some other points around the circle. So let's have these two. All right, so let's say we want to name a semicircle. All right, so there's two semicircles defined by the diameter AB. So the first would be what I would consider like the top half of the circle. Okay, so this semicircle starts at A, goes through the point X, and stops at B. So notice that when you have a semicircle, you're going to use 3 letters to name it, and you're going to put an arc over that. All right, so that's the top half. Now let's say we wanted to name the bottom half of the circle. All right, so again, it starts at point A. This time it goes around and it goes through Y and stops at B. So this would be semicircle A, Y, B. And we want to know that it's an arc, so we put the arc over it. All right, next we have a minor arc. So a minor arc is an arc that is smaller than a semicircle. Okay, so if it's smaller than a semicircle, think that it would have to be greater than 0 degrees, but smaller than 180 degrees. Okay, so basically it's an arc between 0 degrees and less than 180 degrees. Okay, so less than a diameter semicircle. All right, so let's say we have some points here. Let's say we have X, Y, Z, the diameter is marked out by XW, and whoop, then we have, let's see, put a point A down here. Okay, so a semicircle is an arc, a minor arc, is an arc that is less than a semicircle. All right, so an example here, anything less would be, let's see, right here. Here's one, W, Z. Okay, so notice that there's only 2 letters to name a minor arc. 2 letters, okay? So if I choose this arc over here, less than a semicircle, that would be XA with the arc over it. All right, you could have another one right here, YZ. Okay, less than ZY or YZ, less than a semicircle. All right, I bet you can guess what a major arc is. A major arc. So a minor arc is going to be less than a semicircle. So a major arc is going to be greater than a semicircle, greater than a semicircle. All right, so what is that going to look like? Well, you're going to have a circle, of course. Let's see, if we put a diameter on here, then it's really easy to tell where half of a circle is. So we have X, Y, Z, W, A, and B. All right, so a major arc is greater than a semicircle. So let's say we start here at point A. All right, now I could go two directions. I could go to the right and go through W, or I could go to the left and go through B. So you name it by the direction you go and what points it goes through. So let's say I'm going to name a major arc starting at A, passing through W, and I want to make sure it's bigger than a semicircle, so I'm going to come all the way over here to X. All right, so this would be 3 letters, A, W, X. Now, that exact same major arc could be named A, Z, X. Okay, any point that it passes through. You just have to know that the endpoints of your major arc are your first and last letters. You can choose any point in between. All right, so you could also have A, Y, X. All right, so next we have a central angle. All right, so a central angle is an angle whose vertex is, guess where? At the center of the circle, okay? The center of the circle. All right, so let's say central angle, your vertex, write this down, the vertex is at the center of the circle. All right, so you would have a degree measure for that central angle. So let's say we would call that y degrees. All right, now the corresponding arc, okay, marked out by the sides, the rays of your angle, would also be y degrees. Okay, so what we're going to say is the central angle, the measure of the central angle is equal to, I'm going to put a little m over here in front, the measure of the central angle is equal to the measure of the intercepted arc. All right, so all that means is when you have an intercepted arc, it's what is cut off by the sides of that angle. All right, so here we would say the measure of angle AXB is equal to the measure of arc AB. Okay, so for example, if this is 60 degrees, then this arc over here would also be 60 degrees. All right, so next we have a chord. A chord is a segment whose endpoints are on the circle. A segment whose endpoints are on the circle. All right, so what's that going to look like? Obviously, you have a circle. All right, so here's the center. All right, let's have a chord right here. Okay, so the endpoints are on the circle, so that is a chord. All right, you're going to have to name it as a segment, so don't forget to put that line over it. Now, let's say you have something that looks like this. All right, would that be a chord? Yes, because your endpoints, B and C, are on the circle. So BC is a chord, but it is also, what else is it called when it goes through the center? It is a chord that is a diameter, okay? So it can have two names, okay? So it can be a chord and it can be a diameter. All right, so over here you could have another chord. So how many chords would there be on a circle? Well, an infinite number of chords named as segments using 2 letters. Always use 2 letters to name a segment. All right, so next we have a tangent line and point of tangency. So that's a line that intersects the circle in exactly one point. That point is named the point of tangency. All right, so what that is going to look like is you're going to have a circle. All right, so to intersect the circle, ooh, that was not too pretty. All right, you're gonna have to imagine that was a circle. All right, so imagine a line touching the circle in exactly one point. And then this point right here would be the point of tangency. All right, now, let's say you have a line over here. It intersects the circle in exactly 1 point. So this is called your tangent line. And this right here, that 1 point where it touches the circle, is your point of tangency. All right, no surprise here. Congruent circles are circles that have the same radius or the same diameter. All right, they would be congruent. Okay, they have the same radius or diameter. All right, so then you have concentric circles. Now, we've talked about this before, but let's just write it down again. They are 2 or more coplanar circles that share the same center. All right, coming back over here to the congruent circles. All right, so they have the same radius. All right, so let's say this one is 2 centimeters. You could also have this one, okay, if you didn't want to say 2 centimeters for the radius, this one, to be congruent, would have to have a diameter of 4 centimeters. All right, concentric circles. 2 or more coplanar circles with the same center. Okay, so notice the breakdown of the word. Concentric. Okay, so here, basically it's with the same center. So you have a center point, you have a circle, and another circle, and another circle. You can have as many concentric circles as you want. All right, now what you're going to do is pause the video and complete the 2 problems, and yes, you do need to use a ruler and your compass to construct those. All right, our last 2 words here. All right, so the first one, you have an inscribed pentagon. Inscribed is a pentagon inside a circle, intersecting the circle only at the vertices. All right, so if you look at this picture over here, you have a pentagon, okay, 5 sides. It's inside, okay, so that's how I remember. It's inside, it's inscribed in a circle, and the vertices touch the circle only at 1 point. All right, then you have, this one is a circumscribed quadrilateral. A quadrilateral is around the circle. The segments are tangent to the circle. All right, so remember we just talked about that point of tangency. So here you have a point of tangency. You have another point of tangency, another point of tangency, and a final point of tangency. Okay, so if it's a circumscribed quadrilateral, the quadrilateral goes around the circle. Okay, now you could also have an inscribed quadrilateral. That would look like this. If we take these points of tangency and draw a quadrilateral inside, okay, so this one would be an inscribed quadrilateral. All right, so that finishes up our introduction to circles, and we will have some practice problems, so leave some room at the bottom of your paper for those.